Hello folks, welcome to Rational Science. I'm on the road still, and I caught a cold the other day, so I've got my chest congested, my nose clogged, put some nose drops, took an aspirin, and hopefully I'll get through some of the lecture today. It's probably not going to be the lengthiest one, right? So let's get on with the subject matter. I'm going to be talking about these two gentlemen, okay, Sean Carroll and Eric Weinstein. And who are these two individuals? Well, they actually represent the establishment, both of them. That's where they come from. That's what they studied. That's what they were brainwashed with in college. And so this is what they talk about. But it turns out that now these fellows are drifting apart, or seemingly drifting apart. Sean Carroll is sticking with the mainstream, okay, and with the status quo. And Eric Weinstein, on the other hand, he's being kind of pushed outwards, okay. They're telling him that he's a crank, he's a crackpot, or he's becoming one, or he is one already. And so he's having problems with the establishment. What's he trying to do? He's trying to publish a theory. It turns out people like Sean Carroll, not specifically him, but people like him, right, who run the show, who are the peer reviewers, these hooded monks who decide what gets published and what gets not. They're censoring him, or so he claims, that they're not allowing him to publish. And so it turns out he sends his paper to Sean Carroll for his evaluation. And I guess Sean Carroll's the only person who ever read it. And he said, look, there's nothing interesting in there. Nothing new in there for the to trouble the mathematicians out there, the peer reviewers. Okay, so this is what they have, right? And so I guess Weinstein is seeing that as censorship, okay? Hey, you're not allowing my paper to get published. And the other guy says, it doesn't have a chance to be published because there's nothing new there, or nothing important there, or nothing that we want to hear, in there. Okay, so what's the problem? The problem is that mathematical physics, mathemagics as we call it here, is at a crisis. And we're creating this cottage industry of people who were mainstream yesterday, and now they're kind of drifting away from the mainstream. They're saying, look, there's a lot of stuff wrong, or, mathematical physics is stuck. It's a stalemate. It's not moving forward. And so they're criticizing the mathematical establishment from which they came out of, right? And that's what's so interesting. Here you have these new cranks and crackpots. These are the new ones, right? And some of them are very polite, and they don't want to go out there on a limb completely. But in private, I'm sure they have a lot to say. We could hear their voices in private be a lot better. But these people are starting to come out of the closet, so to speak, right? And they're speaking their minds. And a lot of people from the establishment, they don't like that. They're saying what you're doing is debasing all the work that we've done for the last 100 years. All this science that we developed, right? And so there's a little bit of a struggle there. And why is this so? So late in the game, you would think that after 100 years, we would have solved all the problems. We would have fixed all the problems. And what's the problem is here, I guess I can synthesize it as follows. Math phys has painted itself into a corner. That's what's happened. Okay? They can advance no more. There's nowhere to advance. What more equations are you going to develop for quantum mechanics, for example, or for general relativity? All the equations that you could imagine are already there. We already have Schrodinger's equation for quantum mechanics, and Heisenberg's equation, the Dirac equation. You've got them all there. And so there's nothing more to develop in quantum mechanics. In fact, they got rid of quantum mechanics altogether, and people didn't even notice. What was quantum mechanics? What was the purpose of quantum mechanics? How did it start? Well, it started with the quantum, with the, packet of energy, the little ball of energy, and that's long gone. I think it died a long time ago. Exactly when, because these things get drifted over time, more and more people just jump ship, and at some point, one ship is more full than the previous one. That's all there is. And what's happened is they replaced it with a field. Okay, so instead of the single point, now they have this extended field that extends all the way to the edge of space-time. And so, this concentrated point and this extended field, they don't match up very well. And so the question is, what happened? What happened is quantum died. They can't explain anything with quantum. In fact, they can't explain anything with a field either. And the reason is very simple. Field is a bunch of numbers, a value at each point in space. Remember, that's the definition of the word field. And a value at each point in space, what do? They start vibrating the values. They start saying the field is vibrating. What do you mean the field is vibrating? I thought the field was a bunch of values in space. The number 5, the number 6, the number 7, with a unit following it, right? And now they're vibrating all these values until the vibration of the field, And you can't give a physical interpretation with the word field. Field is a mathematical concept, should not be brought into physics. Physics, you need physical objects. I need a rock, I need a dog, I need a house, I need a tree. Those are objects, those are things. You can do things with things, right? You can't do motion with abstract mathematical concepts such as energy, field, charge, time. None of those words can be used to do a physical interpretation. And that's where the problem is. They can't give you a physical interpretation on the one hand, and on the other, they have no more equations to develop. And so where do they stand? Well, they stand, right at the corner where they're painted themselves. They can't get out of that corner. That's the status quo today. And what has happened is, starting, I think, in the 80s, beginning of the 80s, a lot of these folks, they said, look, we want to continue doing math, but there is nothing to develop in quantum mechanics. So what if we do this string theory thingy? There's a lot of math we can develop there, abstract math that has no relevance whatsoever in physics, but they just want to do math. They just want to do equations. And they said, well, we have more equations to develop in string theory. Quantum is dead. We shut the door, all the equations are in. Okay? And so that's the problem. So these people have moved on. The mainstream now has changed from quantum mechanics to string theory, and they're doing equations there. And so the other people have been left behind. They said, no, I'm a traditionalist. I want to continue doing quantum equations, That's what I learned in college, freshman, sophomore year. Well, if you want to do PhD kind of work now, you got to go into string theory. Okay, you got to do equations at a different level or for a different purpose or who knows whatever. And one of the reasons the field is concept, right, is so important is that, general relativity is a field theory. And quantum mechanics is not really. But they did have the word field in there, and they said, what if we replace the particle, with the field? And a particle is simply the local vibration of a field. Again, the number is vibrating there. Okay, no problem. I can handle it. And so we have field, and maybe now with the field in quantum and the field in general relativity, maybe we can put the micro world in contact with the macro world. That's the notion, that's the idea. Quantum gravity or whatever they want to call it. All of it nonsense, by the way. All of it goes into the trash can. None of it survives science. Okay, that's the issue. All of mathematical physics is freaked out. Okay, okay. So what is the problem? What can't they explain? I mean, you have Niels Bohr, who already said anyone who says he understands quantum mechanics is an idiot. He didn't use those exact terms, those are my words, but you get my drift. And then you had, what's his name, Dickie Feynman, and he says, no one understands quantum mechanics. Very straightforward. He said that in the 60s, 63, 64, 65. No one understands quantum mechanics. And so if they who are the proponents of quantum mechanics don't understand their own theory, how can they explain it to you? You say, what's the problem? Why can't they explain quantum mechanics if we have all this technology, we have all the equations, they've done all the experiments in the labs, they have all these particle smashers, right? And they cannot explain quantum mechanics? What's the problem? Well, there are many problems. I'm not going to go through all of them. Let's just put one example that explains it all, okay? Here we have a pencil, Bill Gates' pencil, okay? It's a pencil, okay? And we let it go. And we notice that it falls downwards, right? We call that phenomenon. We call it gravity. Okay, gravity. And the question is, why can't they explain something so simple? You say, Bill, it's not so simple, it's so hard, it's unimaginably impossible, it will never figure it out. Hold it. We have two objects in this system, pencil and earth. You might say, well, pencil, there's a lot of stuff in the room. We have an astronaut coming down to earth, he's falling from the moon, whatever. So we have only two objects, the astronaut and the entire earth. And this guy is falling to earth. So the system consists of two objects, astronaut and earth. Now, how simple do you want it? That's simple. And this astronaut falls to earth at a given rate, which we've measured 9.8 meters per second, right? The acceleration of gravity here on Earth, right? And he's flying towards Earth. So we know the speed, we know the rate, all that stuff. We don't care about the numbers. We just want to know, why does he fall to Earth? Why doesn't he fall to Jupiter? Okay? And so the system consists of an astronaut, the Earth, he's flying to Earth. We don't care about the numbers. We just want to know the causes, the mechanism. Not a single mathematical physicist in the last 10,000 years, from the days of Pythagoras all the way to Einstein and beyond, not one could or can explain why the cause, mechanism, why that astronaut falls to Earth. What's causing him to fall to the Earth? They got all the numbers, they got the rates, they got the values, but they cannot tell you why. They cannot explain to you the mechanism. And that's in a situation with gravity. In fact, that's the one that's missing in quantum mechanics, because here on Earth they cannot explain in the micro world how gravity works. Okay? In other words, why does that pencil fall downwards? And you can't use general relativity for that, because general relativity is a macro theory. It's a field theory. It's for planets and beyond, stars and so on, for big things. Here on Earth, you can't use gravity. You can't say, like some bean brains out there in YouTube, and they show, I'm going to show you warp space here in my basement, or something along those lines. Totally irrational. Totally irrational. No, here on Earth, you cannot have warp space. You cannot use Einstein's equation here in such a small space. Okay, so general relativity is inapplicable here in your basement. So if you have a pencil like I just showed dropping, you cannot explain that saying, oh, the space is warped in this region. Okay, not here. Okay, that's okay out there, not here. Okay, and so Einstein would laugh at you if you brought it to this level. So you need quantum mechanics for that. And of course, quantum mechanics has no theory of gravity. They're trying to search for the graviton, which is supposedly the the particle that delivers negative momentum. Something like a Yukawa potential, as it's called. They put a negative sign in front of the little p for momentum, and they said, okay, the momentum's in the other direction. You throw the ball, and instead of hitting the catcher in the nose and pushing him backwards, the catcher's attracted towards the mound. very scary stuff, Pitcher throws, catcher comes towards him. That's what they have. Okay, so they don't have an explanation for gravity. And so they're trying to look for an equation. I don't know why, because we're looking for people want to know the causes. Normal people out there, they don't care about your stupid equations. They just want to know, give me the cause. Aren't you a physicist? Aren't you supposed to answer these questions? If not you, who? Should I go to my priest? Who do I go to answer the question of why, the cause, the mechanism of why a pencil falls to the earth? If not a physicist. What are they there for? And so that's one big issue, and that's what they're trying to solve. But where does it all start? We've had problems already for 200 years. Forget about quantum mechanics and general relativity and string theory. Even with classical mechanics, we had problems there as well. And where does it start? Well, here it starts. It starts here with these fellas. And they came up with this notion of the transverse wave. The wave really was, the notion of the wave wasn't really put into the system, mathematical physics system, by Robert Hooke, 1665, where he put his Micrographia book out and said that light seems to have a wave nature. And then it was picked up by others, such as Huygens and so on. And so they started developing the wave notion parallel to the particle notion, the discrete particles. So we had the discrete particles and the waves. By the time you get to the beginning of the 19th century, 1800s and thereabouts, you have these people developing the transverse wave. Actually, that fellow there, Fresnel, he's the guy who comes up with this notion of the transverse wave. And what happens, they developed the transverse wave, then it was mathematized by good old Maxwell there, but what's the problem with what you're seeing here? What you're seeing there is that it's a mathematical concept. But you see an electric field. Field? What is a field? Field is where the cows poop, isn't it? No. Field is a bunch of vectors. That's what you see there. Field is just vector. Those arrows represent magnitude and direction. Direction doesn't belong in math because you can't put a number for direction in your equation. So all you can put is a number, and that's the magnitude part of the vector. Okay, so all you have there is numbers. You have magnitude, and these magnitudes form the field, which is a number at each point in space, and they have this thingy full of arrows and lines, and they put it in motion. Very scary stuff. And so this is the problem. They're dealing with a concept, and they're saying this is the mediator of light. The mediator of light is particles and waves. That's the wave nature of light. And so none of it makes sense. Why? Because neither the particle is a particle, it's a bundle of energy, and the wave is also a mathematical concept. So they have these two concepts which they merged in order to cover every base, to make everybody happy, right? The particle physicists and the mathematical and the wave physicists, they're all happy now because they're all covered by this thingy there, and it's not a thingy. What you're staring at is an abstract concept, which they're using as a mediator for light. So this is where the problem is. And so what do we replace this nonsense with? Well, here we just get rid of this ridiculous nonsense that these people invented, and we replace it with a rope. Okay, we have a rope. Okay, so we're going to say that what they've been staring at for the last 400 years, you could even say, since the days of good old Robert Hooke, what they've been staring at is a rope, and they confused it with this mathematized thingy. They essentially mathematized the rope, okay? And they said, oh, look, all these vectors and the fields, it's two fields twined around each other. No, fields don't twine around each other. Fields don't travel 90 degrees to each other because field is a bunch of numbers. That's what it is, okay? So you can't say that you're going to replace a physical object with an abstract concept, a mathematized concept, okay? So that's where the problem starts. And you're saying, well, can it be a rope? Here we have the rope, bgaede's rope, okay? That's what light is. That's the mediator of light. It's a physical entity. Okay? Of course, it's not that thick. Neither is it made out of atoms. People say, what's your rope made out of? It's made out of, listen carefully, it's made out of two strands, twined strands. You know, like DNA, made out of two strands. That's what it is. Period. We're done. Don't ask again what a rope is made out of. Okay? Please try to listen, okay, before one of us dies. Okay, and one thing that the rope can answer is the speed of light. Why light is so fast? The speed of light. Nobody can answer why light is so fast. They say, why is it so fast? And we know why light is so fast in the sense, mathematical sense. We're saying, well, little c, 300,000 kilometers per second, is equal to the inverse relation between frequency and wavelength. Frequency goes up, wavelength goes down. Wavelength goes up, frequency goes down. What do I mean by that? It means that frequency is the number of blips, and wavelength is how thick the blip is or how wide the blip is. That's the description of a rope. Okay, here it is. Okay, so you have the electromagnetic rope, as we call it, and we have C equals frequency times wavelength. Frequency, number of links. Wavelength, the link length, how long the link is. Okay, so of course, if you torque a rope, the more you torque a rope, the more links you have, and each link is shorter. And the more you untorque the rope, the fewer links you have, and the longer each link. That's why frequency and wavelength are inversely proportional to each other, and that's why it's a constant. That's why the velocity of light is a constant, and that's why it's so fast, because the fastest thing imaginable for any human. I mean, I don't care. I'll bet you anything. You bring whatever thing you think is fast, a rocket or whatever, and I'll beat your speed anytime you want. I'll send a torsion wave through a rope, and it'll beat anything that you can imagine. And I always, I did the experiment that you can do at home just to show to yourself, right? Take a clothespin, very tight clothesline, and put two pins, okay? And what I did was put a camera and filmed it and moved one clothespin, and the other one moves instantaneously, essentially. There is a delay, but camera doesn't pick one, the other one moves instantaneously. Why? Because the rope is already connected at the other end. That's why. Every atom in the universe is connected to every atom in the universe. That's why, you don't have entanglement with nothing between two atoms. You have entanglement with something you cannot see or touch, which is very different than not having any mediator. And that's where the problem is. And people say, well, Bill, but I can't see or touch anything, between two atoms. Yeah, of course, because you're using the wrong notion of what a mediator is, what an object is, what a thing is. An object, a thing, a mediator, a body is not that which you can see or touch. An object is that which has shape. All objects in the universe have shape. And if you know of an object that doesn't have shape, hey, I'd like to hear about it, okay? So the universal property of all objects is that they have shape. Uh-oh, I don't know if I'm cut off. Let me know otherwise, okay? Saying that I'm having problems with communication, let me know otherwise, please. I guess they're trying to censor me. I'll wait a second here. Let's see if someone answers, saying that they're not receiving enough. Let me know otherwise. If you can hear me, see me, I'm still here. I think I am. And I'll continue. I'll give it a few seconds. Let me know if you can see me, hear me. Okay, thank you. Thank you. Okay, they just sent me a message from YouTube saying that they were not receiving enough video or whatever. So they flashed me. Anyways, I don't know if you caught what I was saying. I even forgot what I was saying. Anyways, the issue is that the fastest thing you can imagine is a torsion. Okay? Torsion. There's nothing faster than a torsion wave, a three-dimensional wave, not a one-dimensional longitudinal wave like sound. It's not a two-dimensional wave like a standing wave or a transverse wave. No, it's a 3D, you could say. I mean, to use that analogy, right? A 3D torsion wave. Okay, it goes in this direction. It's a spiral. Okay, and it happens along a rope, a physical mediator. Mother Nature doesn't use black magic like in mathematical physics where they have entanglement and action at a distance, which is just the mathematical term for witchcraft or black magic, right? It's voodoo physics. I pinch the doll and it hurts the guy at the other end, you know. Mother Nature doesn't do things by remote control through magic. No, there's got to be a mediator there if you're going to do physics. Otherwise, you're invoking angels and God and ghosts and who knows what else, spirits, right? Okay, so how is this rope of mine constructed? Well, because it constructs also the atoms. The same rope constructs that unifies any two atoms is the atom itself. Okay, so here it is. You have one thread going through the center of every atom and another one going around. Okay, and that builds the atom. All the threads from every rope in the universe converge upon our atom and construct our atom, which is a little star which is encapsulated by a ball. So the famous shell that they've been talking about in quantum mechanics is an actual shell. It's a membrane. It's a balloon that encapsulates a star, the proton star. Okay. The reason, you had Rutherford, he had one atom go through another atom and so on, is because touch is the wrong notion to use to define an object. And that's the problem that Rutherford never figured out. He thought an atom is mostly empty space. No, the region between his two ears is mostly empty space. An atom goes through an atom because most of it is all these threads, and the threads cannot touch another thread. They go right through the thread. Thread goes through thread. Okay, that's why. Now we got it. An atom, an object is not that which you can see or touch. An object is not that which can touch another object, an atom touching another atom. No, an object is that which has shape. And whether it can touch or not, that's a property that not all objects have. I can't see the air. Does that mean the air is not an object? Of course the air is an object, just a thing. It's made out of atoms just like my table that I have here. The table's made out of atoms just like the air that we breathe. They're made out of atoms. And if I could color code the atoms, put them in a little balloon, send it into outer space, pinch the balloon, I can take a snapshot of that blob, and that blob has shape. And people say, well, what is the shape of the blob? Wrong question. Wrong question. The question is, what is the shape? The question is, does it have shape? It's a yes or no type of question. Does energy have shape? Does mass have shape? Does time have shape? Does field have shape? And you can go on and on with all the words in mathematical physics. None one of them have shape because they're all concepts. So you cannot talk about whether any of the words introduced by mathematical physicists have shape. You can't use them as physical objects. Okay, so here we have two atoms, okay, and they're bound by the electromagnetic rope, and as they expand and contract, known as the quantum jump, and that tells you why, Schrodinger and all these other people, they had problems with this because they said, why does a little, in fact, it was actually Bohr who came up with this first, why does a little electron bead, which is a little point on the surface of the membrane, why does it go back and forth? Well, now you can see why it goes back and forth and everywhere. Okay, because it's what they've been describing, all these equations they've had, what they're describing is a shell, a membrane that expands and contracts. By doing so, it stimulates the rope, it sends a three-dimensional torsion wave to the other atom and vice versa. So this is the whole system right there, how simple our universe is. Very simple system, okay? Anybody can understand it. A little baby can understand it. We need no math for this. You can mathematize it later at your own leisure. We don't need that in physics. In physics, we're just trying to explain causes and mechanisms. And here we have another question that Einstein could not answer, and we can answer it very simply with this model, right? And that is why you don't add the speed of light to the speed of the source. The train or your car, you turn on the lights and you don't add the speed of the car to the speed of the light. And here's why. Because, every atom in the light of your car, right, is moving right through the rope. The rope is just going around it. That's what's happening. And so you don't add the speed of the torsion in front of the atom to the speed of the atom. Okay, and so that's the reason you don't add. That's the physical reason, the explanation, something that quantum will never give you. They just do math and not understand nothing. They don't understand nothing. Okay, so here we have our what we talked about the other day, which is the electron, and I'll just finish up with that because my voice is giving out. Okay, so here it goes. Here you have our electron shell. Okay, that's what it looks like. You have all the ropes in the universe, from every atom in the universe, by the way, converging upon our atom. And what happens, they die at the surface of the electron shell, the membrane, right, the electron membrane. And what continues is one of the threads, we colored it blue, arbitrarily, by the way, and labeled it electric thread arbitrarily, okay, also, okay, just to keep with convention. That's the only reason for that. So you have one thread going through the center of the atom and out the other end, where it meets another thread, the magnetic thread, arbitrarily again, that twines around with it and continues as a rope to the next atom. That's the model. Very simple model, essentially. Once you look at it and you say, okay, this is kid stuff. We have one rope, converges upon our atom, dies at the thread, forks out at that point. The red thread, in this case, the magnetic thread, goes around. Okay, and it's remember it's coiled all around. That's why it's got that ball of yarn surface. Okay, that's what we're showing there. And the other one continues, the electric thread continues to the center of the atom and builds the proton star. Okay, so we have the proton star encapsulated by the electron shell, membrane, balloon, however you want to relate to it. Okay, that's the model. And what do we do with this? Well, here you have it. We have this thing shaking, right? That's the best I could do in short time. Okay, so sorry. I could have probably done better, but I think you get the notion. The atom expands and contracts, okay? By doing so, it torques all the ropes that converge upon it. And every atom in the universe does the same thing. So all these ropes are vibrating, out there, gazillions of them. The background radiation, as they call it. Gazillions of ropes from every atom in the universe are vibrating. That's what Penzias and Wilson detected, the background radiation. It's just the vibration of all the ropes in the universe. And they were able to detect that, all those waves, all those vibrations. But there it is. That's the model. Okay, that explains to you what's happening. You have this quantum jump and a torsion of every rope. Okay, so that's what I'm trying to show there. Okay, as crude as I possibly can make it. Okay, now what's the problem with quantum? Let's get back to the subject matter. That's the proposal that we're proposing, and with this we can explain not only light, magnetism, electricity, especially, and gravity, aside from the model of the atom itself. What's the issue? Well, we've been talking about the electron, And we've had problems with the electron because nobody can understand the electron. Partly because no one in quantum mechanics has gone in there and attempted to explain, to define the terms. That's where it starts. We need to define, what are you talking about when you're talking about an electron? Or either define it or make a picture of it so that I can see what you're referring to. Every time you point and say, electron, what are you pointing to? That's what I want to see, right? And they can't do that. They say, well, we don't know what the electron looks like because it's too tiny and we cannot really measure. And no, stop right there. Stop right there. We don't care what you measure. We don't care what Mother Nature's real electron looks like. We don't care what Mother Nature's atom, proton, neutron, we don't care what they look like in reality. That's not the question. The question is, you are giving a presentation. You are giving a theory to the public or to whoever's there in the crowd, right? We need to understand your theory. You have to tell me what your atom, your electron, your neutron looks like. I don't care what Mother Nature's electron looks like. I want to know what your electron looks like. You have to show me your electron, the one you're going to use to make your theory. If you cannot show me your electron, it means you haven't done enough work at the, in your basement, in your dark basement. How can you come to the conference and say, look, I'm going to talk about the electron, the atom, and all this other stuff, but I don't know what they look like. Then what are you going to talk about? And no wonder then, you have people like Dickie Feynman, he says, we don't understand quantum mechanics. Of course you don't. Because you've never pictured it. You never visualized your own theory, your own mechanisms. That's why you can't explain it. And no one will understand it if you can't explain it because you don't understand it. See how simple it is? Okay, so see, these are the fatal problems. I'll just go quickly through them. I went through them last week and go see it in more detail then. But it's important to see what the problem with quantum mechanics is. And the electron is a perfect example. Nobody has ever figured out the electron. So here are the rundown of what I'm going to cover real quick here. No one has any notion of what an electron is, what it looks like. Okay? Can't point to an electron, right? No pictures. They point to something, but then they say, oh, but that's not our electron. So why did you point to it? I mean, what does your electron look like? I don't care, again, about Mother Nature's. I want to know your electron, the one you're going to use in your theory, the one you're going to explain to use to explain your theory, the one you're going to, show us at the conference, right? No definitions or descriptions. And here you have the one from, I made a collage between Wikipedia and the AI. They're essentially one relies upon the other. But here it is. It says, an electron is considered to be a point particle. What does that mean? It means it has no size, it has no volume, no nothing, no area, no shape. So it's 0 volume, 0D, 0 shape. That's what a point particle is. This means it's treated as an infinitely small, dimensionless entity. Well, they have a contradiction right there and then. If it's dimensionless, it's not infinitely small. And if it's infinitely small, it can't be dimensionless. Either it's small or 0D. You can't have it both ways. And they do always have it both ways. They always put both in there. They say, look, small, infinitely small. And then they tell you it's 0D, 0 volume, no shape. Meaning it has no internal structure. That doesn't mean that it has no internal structure. Dimension means it has no volume whatsoever, let alone structure. And its interactions are described as if it's located at a single point in space. The defining feature of a point particle is what? That it lacks spatial extension. Exactly. So don't talk to me about internal structure because you're talking about nothing so far. So far you defined the word nothing. That's what you've defined so far. So nothing cannot have internal structure. Being dimensionless, again, dimensionless means 0D, right? It does not take up space. Again, means no volume, no shape, no size, no dimensions. What else should we put? 0D, right? However, the electron's wave-like nature and the uncertainty principle suggest it occupies a volume. And so they go back and forth between these contradictions. They live with both of them, and they don't care. They just prod on, like bumbling fools. They just say, it's 0D, but it's small. Yeah, 0D is as small as it gets, believe me. Okay, so we have a problem. And then you have these contradictions. They allow these papers to be, they don't allow plural Eric Weinstein to publish his paper, whatever nonsense he's going to publish, I don't care, but they don't allow him to publish. And here they allow this stuff to be published. They show this electron made by the Swedes, one of the universities there, and they say, we took a film, not a picture, but even they filmed the electron riding a wave. So there's your electron. So hold it, that doesn't look like 0D to me. And how come they say that they can't see an electron, that it's beyond their capability? Then they film it and they allow this to be published. And even worse, in my small mind, right? I mean, why did these guys get a Nobel Prize? I mean, they should have gotten a Nobel Prize for filming the electron for the first time in the history of humanity. And nobody gives a damn about this. They only bring it up when they say, oh, we filmed the electron. How did you film the electron if you're telling me it's 0D and that you can't measure it because it's so small you can't even see an atom? I mean, these people can't even draw an atom, and they filmed an electron and they allow this garbage to be published? Who were the peer reviewers for this paper? How come this got through the peer reviewers? That's what you should ask yourself, okay? So yeah, I got a problem with that, because on the one hand they say it's 0D, on the other hand they film it and they say, oh, we got away with it. And they allow this garbage to be published. They allow garbage like Many Worlds to be published. They allow poppycock such the holographic universe to be published. So much garbage they have out there, and they're worried about this guy, Eric Weinstein, trying to publish his theory, which is nonsense also, I'm sure. But I mean, they publish so much garbage, they can publish his garbage as well. I mean, who cares? I mean, who's going to read it anyways? It's just that they just want to put their thumb on top of poor old Eric, say, hey, we're going to squash you, bitch. We want you to publish your garbage, but they're publishing all this other nonsense, so I don't know. And once you know that it's a point particle, a little point that's vibrating there or titillating or whatever, then they tell you, hey, they brilliantly showed that it's a wave. The electron is a wave. It's a hula hoop that surrounds the proton. What? I mean, is it a little point particle, or is it a wave that goes all around? And yeah, it's like I'm saying, it's a whole, and then they came up with a cloud notion also of the electron, that it's everywhere. And so, yeah, essentially they're describing the rope model of the atom. They're saying it looks like this. That's what it is. There you have a wave. I mean, a cloud, the cloud model of the atom. Okay, so what else do we have here? We have electron is not an object, okay, because it's really a charge, a quantity, 1.6 times 10 to the minus 19 coulombs, a negative in the case of the electron, positive in the case of the proton. Great. But as I discussed the other day, we have the issue where you have the proton and the neutron. They're made out of quarks, and we had this fellow's name is Murray Gell-Mann, and he came up with this notion that we have three quarks, and with that he could explain why with two up quarks and one down quark you can show that the proton has one charge, 1.6 times 10 to the minus 19 coulombs, right? Whereas the neutron has no charge because we have two down quarks and one up quark. You just subtract, it's just a math thing where you subtract one from the other and you end up with zero charge. And so with that he was explaining why the proton has charge and why the neutron has charge. Okay, great. Give them a Nobel, which they did. How about the electron now? How do these quarks, this quark system that you created, how does that relate now to the electron? Does the electron is it also made out of quarks so that you have 2 or 3 or 4 or 10 up quarks and 500 down quarks, and with that you get a negative electron charge. Is that how it's done? So here, let me show you what I'm talking about. Here it is. You have the proton there. You got 2 up quarks, that's 4/3 minus 1/3 of the down quark. You get 1 3/3, in other words, 1, right? And the neutron's in reverse. You have 1 up quark, 2/3 minus 2 1/3, that's 0. Okay, so that explains why proton has charge and neutron doesn't. How about the electron? Electron has a negative charge. How did the quarks fit in there? And so they don't have a quark system for the electron. It turns out that they're cheating because the system only works for neutron and proton. It cannot be extended to the electron, and without that, you don't have you have not finished your theory. It's not a comprehensive theory. Okay, they cheated to get that Nobel Prize. They cheated because they applied it only to the proton and neutron, and they forgot about the poor little electron. They have no explanation for that, even though they filmed it, right? They filmed the electron. I mean, if they're going to film it there, they might as well, dissect it a little bit and find out how many quarks are in there, how many gluons. You would think at least they would do something like that, right? But they haven't been able to crash electrons against electrons and bust them into pieces, I guess. They need the size of the galaxy to do that. Okay, so we have a problem with the electron. It's not made of quarks. Sorry, guys. Then we have the problem why it doesn't fall to the nucleus and why it doesn't fly away. The electron, the first question, the reason they started investigating quantum is that they said, why doesn't the electron, if it's losing energy while it rolls around, why doesn't it fall to the nucleus? And people say, well, it's like the planets. The planets don't fall towards the sun. Well, why? I mean, why doesn't Pluto fall towards the sun? And he said, because, and we're done. They say we have all these number lines that are warped, and they maintain Pluto running around the edges of the solar system. So they don't have an explanation. They just have a mathematical description based on number lines, which they represent with a fishnet, a warped fishnet, and they say that's it. That's our explanation. And so why is the fishnet bending downwards? Why doesn't when you throw fish on a fishnet, it pushes it downwards. Why? Because of gravity. Because gravity pulls it, whatever gravity is, right? It's pulling it towards the center of the earth. Why doesn't it pull it upwards, the net upwards? And they never have an explanation for that. So here's the problem. The problem is that the electron doesn't fall to the nucleus, loses energy and falls into the nucleus, and the other one doesn't fly away. I mean, why not? Why doesn't the electron go and fly out? Why doesn't the moon fly out of the solar system? Why doesn't the moon fall towards the earth? Why doesn't the earth fall towards the sun? No explanations. So we have no explanations. All we have is mathematical descriptions. And right now they ran out of descriptions because all the equations are out. There's no more equations to be developed in quantum mechanics. And so now they're panicking because they don't have any future. And so they say, hey, we fix this very easy. We create this nonsense called string theory, and we all move into string theory. We continue the job security forever, right? Okay, the other problem is electricity, flow of charges, right? And you can't have a flow of charges because charges are numbers. 1.6 times 10 to the minus 19 coulombs. They're flowing, all these numbers, they're flowing. And that's what electricians do. They measure. They say, we measured how much charge is at this point. Yeah, you measure, but you don't know what you measured. And they think there's little beads moving sideways, in the wire. And that's what an electrician thinks, because that's what he was taught in school. So he just goes in there, puts the probe, says, okay, I measured the charge. The charge is so much, and he just puts numbers because he's talking about quantities, and he can use that for something. But he cannot tell you the nature of what's happening inside the wire. And he just assumes that, whatever they taught him, that just little ducks going along the wire, that's what electricity is, a bunch of electrons moving along, from atom to atom. Is that what electricity is? And we have a problem because this is where we stand here today. We have these notions that we picked up from the 19th century, about 1850s onwards, thereabouts, I talked about that a little bit the other day. And what you see there is a vacuum chamber. You have all these atoms. You can assume what we used to do in the industry, in the semiconductor industry, we had a vacuum chamber, right? And we evacuated it, usually to the -7 torr level, okay? And you have these plates, right? Cathode, anode, right? And you charge them up, and what you have is you introduce a species such as argon, a neutral species. You ionize it, and then you use the ions, supposedly, or the electron, depending on what you're trying to do there, as bullets. And you throw them against the target, and it's like a machine gun shooting against a wall. All the bricks pop out. That's exactly what you're doing with one of these chambers. But you have all this chamber there. You evacuate it. Now you have an electricity flowing in there because you introduced a gas, argon, for example, right? Okay, so you have all the electron beads, the blue ones there, and they're moving across from one plate to another. No problem. So far, we more or less understand that, right? What's the issue? The issue is that they got rid of the atom. In quantum mechanics, they don't use the atom anymore. Now it's just the electron beads flowing through the air, okay? And so if you want to send electricity from one star to another, like they do in the electric universe, right? These bean brains over there, and they have all these filaments, that power the stars. I absolutely love this shit. They have all these filaments connecting one star to the other, and they have all these electron beads moving from one star to another. No atoms in between. They just have the electron beads moving. By what mechanism? I mean, they're all discrete. And then they say all these filaments, they bind all these stars together, and that's gravity. How can you bind with discrete beads moving from one star to another? So the whole system of the electric universe is irrational, aside from the fact that you won't find a rational definition of the word electricity. I mean, they're talking about the electric universe, electricity, and they don't know what electricity is. They say it's the flow of charges. What do you mean the flow of charges? Where did you get this nonsense? And what you have is that these people are relying, they want to do some classical physics, normal, imaginable physics, but they're using quantum stuff that came after the turn of the century, the 20th century, right? They're using the quantum electron, right, which is a quantum object, one that has all these fancy properties like, entanglement and complementarity and superposition, that it's everywhere in one place at the same time. They have all these properties. They call that a quantum object. And the electricians from the electric universe are taking this quantum object that has all these magical properties, and they say, we want to do imaginable physics by showing, that electricity is what powers the entire universe, including gravity. Yeah, they're going to be laughed out of the conference. That's what's going to happen. And that's why the electric universe has no chance whatsoever in science. We got to get rid of these people. They're just in the way. Anyways, they got rid of the atom. Okay, we don't need the atom anymore. We have just the electron beads flowing, right, through space. And what can I say? This is the status quo, not only for the electric universe, but also for the quantum mechanics. They also use this model. That's their model of electricity. Okay, so we don't need the atom to flow. And then we have the quantum jump. It's not explained. Here we have the quantum jump, okay? This is the quantum version, right? We have a little bead there, the red electron bead that jumps back and forth. It also goes around, but I just had it there. It doesn't really matter. And by jumping back and forth, it sends out these waves, this energy, whatever it's called in quantum. And they don't know why, but it goes outwards. When it comes in, I guess the wave comes back in. So you have this energy going back and forth, whatever energy is. And, of course, they don't know what that is. So all they have is a mathematical description of a little bead jumping back and forth for no reason whatsoever. They cannot explain why the bead doesn't fall to the nucleus. one being negative, the other one being positive, and they don't understand why the electron bead doesn't spontaneously fly away. So we have all these contradictions, all these unanswered answers, right? And this is what they have today. That's why if you don't understand anything while you were in high school, don't feel bad because they don't understand it either. Okay, that's the situation today. Okay, so well, just one final note here, and that's that you have the negative electron bead, and again, you say, well, why does it fall to the nucleus, which is positive, right? You would think that the electron bead, negative, is attracted by the positive proton and whatever there, right? Okay. It don't, and it does. It does both. Here it is. The quantum p orbitals, you have the electron bead. It goes right through the center of the atom and out the other end. And so, yeah, you have this, and you say, well, hold it. Why does it stay in the center of the atom? And they have no explanation for that. And so some people, what they do is they do a little cheating. They say, well, the electron bead gets close to the nucleus, but it doesn't go that extra mile, and so it just comes back. So it's whizzing around the p orbital, right, without ever getting too close to the proton. Okay, for whatever reason, and they come up with nonsense to explain that as well. And again, it's all mathematical nonsense. They talk about energy. They say it's the energy, but they don't know what energy is, so we don't have a physical interpretation of why that electron bead doesn't not go all the way to the center of the atom. They have no explanation for that. It just is. You don't like it, you don't belong in mathematical physics, okay? Okay, so they misconceived electricity. This is the atom, and because of that, they have this wrong notion of current, that an electron bead is going from atom to atom, right? Then they got rid of the atom itself. Okay, great. But this is a misconception that they have of electricity. Here's the bead measure version again of going from atom to atom. How do we replace that? We replace that with merged electron shells. They're all merged. You can't do it without atoms. They're all merged. And really, these are molecules here. I represent it with a hydrogen atom, but you got to think of them really as molecules, and they're all blended. Some of the atoms from one molecule to the other are blended with each other, right? And they all twirl in situ, right? Long strings of molecules, right? And they spin in situ, and that is electricity. What is that positive? What is negative? Clockwise, counterclockwise. Mother Nature doesn't understand what positive, negative, north, south is. Mother Nature understands clockwise and counterclockwise. That she does understand, okay? Okay, so that's electricity. That's in general terms, just so we can go into a lot more detail later on. In fact, I will probably do it on Wednesday. We'll continue with this. My voice is giving out. But let me just finish up with gravity, okay? So something that mathematical physics has no answer to, either in general relativity or in quantum mechanics, not to mention string theory, which has no answer for that at all. They just have a bunch of math. They don't have any explanation. They never will, because it's all math. And so here it is, okay? Here's the reason, the cause, the mechanism for gravity proposed by the rote model. Okay, every atom in your body, let's say you're the astronaut, right? Every atom in your body is connected to every atom on Earth. Okay, and so as you approach the Earth, the ropes fan out. The farther away you are, all the ropes come together, and gravity is weak because they all act as a single coaxial, single rope, you could say almost. They're all superimposed. And as you approach the Earth, the ropes fan out, so each one works or acts independently, okay? And so now, you have the acceleration of gravity. The closer you get to the center of the Earth, the more the ropes fan out. Okay, very simple stuff, really. Okay, I hope you can picture that. I hope this is not out of the reach of your mind, okay? You should be able to see this and say, okay, I understand what he's saying. Every atom in the astronaut's body is connected to every atom on Earth, and that's why he falls to Earth at an accelerating rate, because as he approaches, the rows fan out. Simple stuff. You have questions, put that in the comments section, okay? And people say, well, Bill, where did you get this notion that all atoms are connected to each other? This ridiculous notion you have. Okay, so don't listen to me. I don't know nothing, okay? Let's go to Mr. Richard Muller from Berkeley University. Hopefully you'll listen to him. He's a guru of mathematical physics. He'll tell it to you in your face, okay? So here it is. Listen to him carefully. He'll tell you exactly what I just said. Listen carefully. Here goes.
If you have Earth, with a big mass here, and you have you, with your little mass here, that every atom on the Earth is pulling on every atom of you. You're also pulling on it. You're pulling on atoms right now on the other side of the Earth. There's a lot of atoms here you're pulling on. You're pulling on all of them. The amazing thing about gravity is it goes right through things.
So what part did you not understand? Every atom on Earth is pulling on every atom of you. Every atom of you is pulling on every atom of Earth. The only way you can pull, one atom can pull on another, is if there's a physical entity, mediator, that binds them. If there ain't one, you're doing black magic. You're doing what the mathematicians call action at a distance, remote control. You're doing voodoo physics. I'll see you on Wednesday.